Good morning to one and all. My name is V. Avijit Kumar. My roll number is 24951A6602. I am studying in CSE AI and ML, that is Computer Science and Engineering with the specialization of Artificial Intelligence and Machine Learning, 4th semester, Institute of Aeronautical Engineering. In this video of the complex engineering problem of the subject of database management systems, the topic I am going to speak on about is Crimemap AI. So let's dive into the topic. Now let's go through the contents. In the first place, I'm going to introduce the topic. That is, I'm going to explain the overview of the Crimemap AI and its purpose. And in the second place, I'm going to explain the problem statement. That is, I'm going to explain about the challenges we face with existing crime database systems. And after that, I'm going to explain the proposed system. That is, I'm going to explain about the architecture and capabilities of Crimemap AI, and after that I'll go to the implementation, DBMS design, the database structure, relationships and SQL queries, and after that I'm going to show the execution query results, that is the query outputs and the result, and after that I'm going to conclude the topic with an overall summary. Hence, this is the contents slide. Now let's go through the introduction. Crimemap AI is a data-driven system designed to store, manage and analyze crime-related data using DBMS. In modern cities, crime data is voluminous, unstructured, and impossible to interpret manually. Traditional systems store data but deliver no actionable insights. Here, MySQL DBMS, that is MySQL Workbench, provides structured relational database relational storage, that is a table for all crime records, and analytical queries. The SQL powered pattern detection across large data sets is possible, and the logic, the AI logic, it helps in identifying hotspots, trends, and peak crime hours. Hence, this is the introduction. Now let's go through the problem statement. Current crime data management is fundamentally broken. Data is scattered or unorganized and yields no predictive value for law enforcement. Here we have four key problems. One is fragmented data. The crime records are siloed with no unified structure. The next is no risk mapping. The high risk areas cannot be identified proactively. Temporal blind spot. The time-based patterns go undetected without analysis. Poor decision support. Authorities lack intelligent data-backed insights. Hence, this is the problem statement. Now let's go through the proposed system. The Crimemap AI. Crimemap AI is a DBMS-based analytical platform that transforms raw crime records into actionable intelligence using structured relational tables and advanced SQL queries. Here I have to discuss about four qualities of Crimemap AI. The first quality is structured storage. The crime data stored in normalized relational tables for fast retrieval and integrity. That is the storage, the structure of the storage, and hotspot detection. SQL aggregation queries identify geographic areas with the highest crime frequency. Peak hour analysis. The temporal grouping reveals the hours and the days when crimes occur most frequently. Crime type ranking. Frequency analysis surfaces the most common crime types to prioritize policing. Hence, this is the proposed system, the Crimemap AI. Now let's go through implementation, the DBMS design. The database schema is divided into three sections: the users section, the user ID, name, role; the crimes, the crime ID, crime type, location, latitude, longitude, date, time, description. These are all the crimes; and the reports, the report ID, user ID, crime ID, and the status. These all are the primary functions, the primary elements of the database schema, and the analysis queries that implement AI are: select location, count pointer as total from crimes, group by location, order by total desk, that is total description. These are the crime hotspots, and the most common crime is selected by these commands: select type and count pointer as count from crimes, group by type. From here, the most common crime is extracted, and the peak crime hour, that is select hour, date underscore time, and count pointer from crimes, group by hour, date underscore time. By executing these commands, peak crime hour can be extracted. The relationships are as follows: users are related to reports, that is, one user can report many crimes. The one crime can be reported many places, at many places. Between users and relationships, there is a one-to-many relationship, and between the crimes and reports, there is a one-to-many relationship. Hence, this is the design of the entire database management system, the relational database, and this is the entire implementation. Now, execution of the query. All tables are successfully created, the sample data is inserted, and the analytical queries return the expected as outputs as shown below. The crimes table, as you can show, the sample data with inserted rows, the reports table with inserted rows, the hotspot queries result with the data from the crimes table. The crime type frequency is extracted from crimes table and reports table. The peak crime hours are extracted from crimes table and reports table. Hence, this is the execution of the commands. And finally, I would like to conclude the topic by saying that Crimemap AI demonstrates that a well-designed DBMS is far more than a data store. It is a powerful analytical engine capable of simulating AI-like intelligence through structured queries alone. Hotspot mapping pinpoints it pinpoints high-risk geographic locations from aggregated records. Pattern recognition: it surfaces frequent crime types and temporal trends via SQL. And decision support: it delivers data backend insights for rapid law enforcement response. Even without advanced machine learning, DBMS driven analysis can deliver real world impact in public safety and crime prevention planning. Hence, this is the entire conclusion. And finally, I would like to thank the respected professors for giving me this wonderful opportunity to talk upon this wonderful topic. Thank you.